Thank you everyone for joining us on our first Arduino workshop of the fall semester, brought to you by the Math and Science Club and the Society of Hispanic Professional Engineers.
Hey.
Hey. So what we'll be going over today, what are Arduinos, some circuit basics, using a microcontroller and a breadboard. We will then create a circuit and add some code. All right. What is Arduino? So Arduino is an open source hardware and software company. They provide microcontroller boards used for designing and creating interactive objects and environments. They're not the only company. There are some other ones that are cheaper, more feasible, but they just have a cool platform for beginners, intermediate, personal use. Some possible applications are robotics, sensors, weather monitors. You can make sound. There's a lot of options. And maybe, Raul, you can show us some of what you got at the end, if you're willing. All right, so circuit basics. First, we're gonna go over voltage. So voltage, represented as V, is the electric potential between 2 points. This is what's gonna power our circuits. Now, in this case, the 2 points is gonna be our positive and our negative, as in ground. You can consider voltage as energy per units of charge. For us, we're gonna be using the left equation. I mean, we don't have to use equations, but just for reference. Voltage is equal to I, which represents current, times R, which represents resistance. Okay. And at any point, if you have any questions, please feel free to say something or post something in the chat. All right, cool. Resistance. Resistance is the measure of opposition to electric current. We'll be using resistors that limit the amount of current moving through a circuit. So we can arrange resistors in two types of ways, parallel and in series, okay? And this is important because depending on the arrangement, it actually changes the amount of resistance that you get. So depending on what you're trying to do, you know, what you're working with, you might have to choose one or the other. So let me just choose one. Here we go. Cool. All right. Let me try. Okay. Can you guys see that image all right?
Yep.
Yes.
Okay. So here we have a circuit in series, resistors in series, sorry. When they're in series, you just add them all together. Now, when they're in parallel, the way we calculate the resistance as a whole is a little different. So here we have 1 over R equals, right, 1 over resistance 1, 1 over resistance 2, 1 over resistance 3, and so on. You could even consider this as like 1 over this whole equation on the bottom, right? So let's give an example, right? Let's say I have 2 resistors, right? I have 2 resistors, both equaling 5 ohms. That's how we measure resistors. So we have 2 of them, okay? In a series, that equals to how many ohms?
10.
Oh my goodness, brilliant. All right, sorry. So cool, 10. Now in a series though, right? The whole equation would be 1 over, all on the denominator, 1 over 5 plus 1 over 5. So put that in my calculator because I'm lazy. 1 over 5 plus 1 over 5.
2/5.
2.5.
2.5. So that's half, sorry, not half, a fraction of the resistance as if they were in series. Okay, so if you think about, what's it called? Christmas lights, right? They were once, I think, in series, right? And then they changed them to parallel.
Yep.
It's more efficient. Okay, so the next one, current, which we present as I. Current represents the flow of electricity in a system. Moreover, you could say that it represents how many electrons per second are flowing at any given point in your circuit. This is measured in amps. And on the equation to the left, we see that I, current, is equal to voltage over resistance. So you increase the voltage, you increase the current. Inversely so, you increase the resistance, you decrease the current, right? You decrease the current, you decrease the resistance, you increase the current. All right. One other little tidbit that I'm bummed it doesn't show up. Juan, make sure that I get this correct. So for resistors in series, the voltage stays, no, hold on. Yes.
Current. Yeah, if they're in series, the current is the same.
Okay, so the voltage is what's changing, right?
Yeah, so there's voltage drops across these resistors, yeah.
Okay. Now in parallel, the current actually changes and the voltage stays the same.
Exactly.
All right, and I had a diagram to show you guys, but it's not showing up, so kind of a little bummed about that. But so here, right, in series, I'm gonna get a little, where are you? Pointer. Okay, we add them one after the other, right, and here, a little different, okay? So this kind of shows the way that the current, okay, stays the same, but we have different voltages here. And here you can see how we actually end up having different current, okay, same voltage. Here is the, okay, diagram for current. So here, right, this current is the same as this one. Here, the current stays the same throughout, but in a parallel circuit, you can imagine the current like water, okay? So as the current flows through into the circuit, right, it gets dispersed out, creating a current here, current here, current here, right? All of their own, different from the initial current. Okay. That was just a basic circuit for you guys to see what a resistor looks like in a diagram. Here's an LED. Okay, here's the battery. Positive, goes around, back to negative. All right.
Which way does the electricity flow?
From positive to negative, this way.
So then what we do is that we put the resistor before the LED from the,
Yes.
going from the positive to the negative. That way we restrict the voltage going into the LED.
Exactly. Yes.
It could be you could put it in front or after.
Or after?
Because if it's a closed circuit,
It'll
it doesn't
choke
matter
it.
where there is it doesn't matter where the resistance is because it's a closed circuit in and of itself.
Oh.
There we
Yeah.
go. Good to know.
Which is kind of confusing, but yeah, you can put it in front if you're starting.
Just trust the process.
Yeah.
Yeah, that makes more sense, right? Because you kind of like reduce the voltage before it goes into the LED. But I guess.
Yep. So, all right, microcontrollers and breadboards. So this is basic Arduino microcontroller. Here, USB to plug into your computer or device. We're going to be using these right here. So we have output pins right here, a output pin for 5 volts. This is going to be your positive, and then we have ground, which is going to be your negative. Okay, and then we also have these pins right here where you can connect them to your circuit, and it allows you to add code and manipulate your circuit. And just a little tidbit, we're trying to get you guys microcontrollers. The ones that we will be ordering are not Arduinos just because they're more feasible. So it'll look a little different, but I think most of them, all of them, they have these written on them, right?
Yes.
Yeah.
Yes.
Okay. Okay, so this is a breadboard. This is a chunk of it. It's usually like longer. So we have positive ends, right, and negative. Here you can imagine there's metal going all along here. So these are all connected. These are all connected. These are not connected to each other. This is not connected here. Okay, and then we have these rows right here, pieces of metal that are all going along here. This row is not connected to this one, and these columns are not connected. They're split. Okay, so just keep that in mind. Do we have any questions? You good?
It's pretty good.
Cool. All right, now creating a basic circuit. All right, so I'm gonna show you guys what you're gonna do. I'm just gonna show you real quick, and then I'll, let you guys kind of do your own thing for about like 5-10 minutes, and I'll leave my screen up so that you can reference it if need be. So on the Tinkercad homepage, you're gonna create a new circuit.
Sorry, make sure that you guys like log in and stuff first.
Yeah. If you want to be able to save your work. All right. So on the right, you can see that there's a bunch of little widgets, okay? We're gonna use Arduino Uno, right? You can just click on it. You can hold Shift and then R to rotate your device. I'm gonna put it right here, okay? You can drag around to on the screen. And then we're gonna add a breadboard. Okay. Put this bad boy like right here. All right. Okay. So, just for basics, I'm going to connect my 5-volt to the positive end. Okay. You can change the color for neatness if you get to making a more intricate circuit. Red for positive. Okay. All right. Now, I'm going to show you guys just a little basic example. So, rotate. Oops, wrong way. You guys can you guys see my mouse? Is it in the way?
I can see your mouse, but it's not in the way.
Okay. All right. So the bent prong is the positive side. Okay. So in real life, the longer end is positive. Okay. So I'm gonna put a little LED. Put it right here. Okay. Okay. Got an LED. Cool. Red. Add a resistor. Before or after, doesn't matter. Cool beans. Okay. All right. So I'll make a very basic one just in the meantime. Well, okay. Now we're gonna connect negative to ground. All right. Cool. It lights up. Okay. Now, watch when I take out the resistor. Look what happens. Okay. So resistors are important because many times the voltage going in might be too strong for your device. Having resistors helps, prevent anything from, I guess, breaking in a sense. So, cool aspect about this platform. Okay, current through the LED is 483 microamps, while absolute maximum is 20 microamps. So in this case, we fried the LED, right? We don't want that. So it's very important that when you are, comment in the chat.
Milliamps.
Milliamps, sorry, thanks for correcting me. So milliamps. So it's really important that when you guys are, working with circuits, that you're aware of how many volts your little gadget can take. Oh, I don't know why I deleted that actually. All right. So basic resistor. Okay. All right. So I'm gonna leave that. Give you guys like 5 minutes to do that, and then
it.
yeah. So.
Oh, you know what would be cool? It's if like have them use V equals IR. Like if it's 5 volts, right, and it needs 20 milliamps, what would be the resistance that you need in order to get the 20 milliamps? If you have 5 volts.
Yeah, that is a great question. So we don't want it to draw more than 20 milliamps. Let's just say that we want the current to be exactly 20 milliamps. What does, and we know that the voltage being provided is 5 volts. That's a great question. What does the resistance need to be in order to meet those requirements? So voltage is 5. The current is well, milliamps, so that would be
Times 10 to the negative 3.
Yeah, so
So
0.002.
yeah. No, 0.02. Because it's 20 milliamps. So 0.00.
Oh yeah. Okay, cool. So Luis, once you log in, and you get to this page, what is it? Your dashboard. You're gonna look for circuits. So you might be on 3D designs. You're gonna want to click on circuits, and then you can try circuits or create a new circuit.
Create a new circuit, yeah.
Yeah.
How did you turn the components? Because mine are just like horizontal and I want them vertical.
So capital R. So hold shift and then press
okay.
R. Yeah.
Rotate.
Yes. And then also I found, I think it's shift F. Yeah, shift F lets you inverse your, so flips it like that.
It worked.
Yeah.
That's what we like to hear.
Yes.
Wait, what is supposed to happen?
The LED is just supposed to turn on right now. So what we're going to work on right now is can we control turning on and off that LED using programming? But right now we just literally want you to get familiar with the platform. So just
yeah, and I don't know if I didn't mention it, I just did it, my bad. But you have to start the simulation. You have to start and stop it. So on the top right, you have a bar for code and then start simulation. So that'll turn on your LED.
Wait, my
But you-
LED is not turning on.
do you have it connected correctly is the thing. Oh.
So you can take another look. If it
Yep.
seems correct and it's still not working, let us know. But yeah, you do have to start the simulation on this. And it'll turn green.
Oh, never mind. I didn't start it.
Cool.
It hadn't worked. I didn't know we had to start it.
Yeah. How did you get the gray bar? What is the gray?
That's the breadboard. So you just scroll down and it's right by the 9-volt battery and this 1.5. So it's right next to the, kind of next to the Arduino.